All right, so a new treatment is believed to reduce the level of uric acid in blood of gout sufferers. A study was conducted where patients were assigned to the new treatment and an old treatment. The results were reported as the number of patients that reported significant reductions in uric acid levels. Does this information suggest the proportion of patients that reported a reduction is independent of the drug type? Perform the appropriate statistical test to make your decision at the 1% significance level. Show your work and write a sentence that puts your answer in the context of the problem. So this is a two-proportion z-test. So the proportion that had the new drug was 90 out of 150, which is 60%. The proportion that reported the reduction with the old drug is 75 out of 150, which is 50%. We have to assume that we have an independent simple random sample. The normality assumption is justified because n times p and n times q are both bigger than 5. This is our combined proportion, right? So I have 90 out of 150 and 75 out of 150, so I treat that as one big sample. 90 plus 75 divided by 300, so that gives me a combined proportion of 55%. So here's the formula for my z-score. So it's 0.6 minus 0.5 minus 0 divided by, there's an error here, so it's 1 over 150 plus 1 over 150. So there's a plus in between there, right? So this is 1 over 150 plus 1 over 150. That's what should be showing right there. Times 0.55 times 0.45. So we crunch all that out. We get 1.74. So our null hypothesis is that the proportions that reported reductions are the same. The alternative is that the proportion of the new drug is bigger than the proportion of the old drug. So I've got my z-score is 1.74. And so we do the probability that our z-score of 1.74 occurring by random chance is approximately 4.1%. And so we can do that by doing the stat test one proportion z-test, or I'm sorry, two proportion z-test, right? So we're going to go stat, test, two proportion z-test, and we've got 90 out of 150, and we've got 75 out of 150. And we're doing a one-tailed test, and we calculate it. So there's the 1.74. The probability is 4%, which seems small, but our alpha level is 1%, so therefore we do not reject the null, because we don't have enough evidence to suggest that the new is actually better than the old.